So I'm doing segment 3 of chapter 18 for this week's reading, starting off with simple effects. So whenever an interaction is statistically significant, new FCE tests can be conducted to identify inconsistencies among simple effects that produce an interaction. These new tests require that by ignoring the second factor, the original two-factor ANOVA can be transformed into several one-factor or simple effect ANOVAs. The test for simple effects. A test of the effect of one factor of the dependent variable at a single level of another factor. Now, inconsistencies among a set of simple effects are usually associated with a mixture of both significant and non-significant FCE tests for that set of simple effects. So you could test one set, preferably the one that seems to describe the significant interaction best. Then we have FCE test for simple effects. The new FCE test for any simple effect is very similar to the F test for the corresponding mean effect in a two-factor ANOVA. The degrees of freedom in the denominator is still MS within. However, the numerator term must be adjusted to estimate the variability associated with just one row or one column, which would be MSSE. So the degrees of freedom for the numerator of the simple effect FCE ratio is the same as that for the corresponding main effect F ratio, which is DF between, so using like C minus 1 or R minus 1. The degrees of freedom for the denominator of the simple effect FCE ratio is the same as that for any two-factor F ratio, so DF within. So the FCE ratio for simple effects is FCE equals MSSE divided by MS within. Calculating FCE, so you could do the computational way. So doing SSE divided by its degrees of freedom equals MSSC, and that's the sum of squares simple effect equation. I want to talk about Tukey's HSD test for multiple comparisons. If a simple effect is significant and involves more than two groups, this test can be used to identify pairs of some means that differ significantly. Then we go on to talk about estimating effect size. So significant difference between pairs of means can have its effect size estimated with Cohen's d by using that equation below.